All right, here's basically the second part to section 5.1. What we're going to do today is we're not just going to take a fraction and just try to simplify that fraction. We're not doing multiplication, we're not doing division. We're going to do addition and subtraction. And I think the reason they do addition and subtraction secondly is because I think addition and subtraction is a little bit harder when you're dealing with fractions and multiplication division. Would you agree with that? Normally when you're a kid, you probably learn how to add things first, right? Then you subtract, and then after that, you kind of accomplish that. Then you go to multiplication and division. But in fractions, I think it's a little easier to multiply and divide. So let's go old school right here. I'm just making this up off the top of my head. Let's go 3/5 plus 4/7. Okay, and we're gonna add these together. It's not multiplication; it's addition. What is the key thing when you add fractions? Common denominator. That's right. So I got to find a common denominator. So I got a 5 and I got a 7. All right. So they're just prime numbers. So all you got to do is just multiply those together and you get 35. That's your common denominator. I'm going to do this a little bit differently than what you might have learned when you first learned how to do fractions. Remember you're a kid, you did stuff like this. You did it up and down, right? And then what'd you do? Didn't you learn it like this? Right? You put a 35 here, and what'd you do? You went times 7, do you remember this? And times 5, and you did the whole thing. Right? Well, that's good when you're a little kid and you're first learning that, but in algebra, we do things across a lot, okay? Especially with fractions, we add things across like this. So let's just kind of get used to doing it this way, all right? So we might have to change your way of thinking just a little bit. You're doing the same thing. It's really not any different. But a lot of times, we work across when we're doing these things. So 5 and 7, the common denominator is 35. Now, if you want to write times 7 in here, you can. But I think at this point in our math career, I don't think you have to do that. You can just look at it. 5 times what is 35? 5 times what? 7. So you do the same thing to the top. Just do that in your head. 3 times 7 is 21. You just put it right there. You're okay with doing it like that now, aren't you? Okay, there's a plus sign. Then you do the other denominator. How'd you get from this denominator to the 35? 7 times 5. So you multiply the top by 5. 4 times 5 is 20. Everybody with me? And then now you just add up the top. It's at 41 over 35. And you just keep it like that. When you're a kid, your teachers always harped on you to not keep it an improper fraction. In algebra, a lot of times it's even better to have it as an improper than a mixed number. Okay? There's times when it's okay to write it as a mixed, but I'd say for a lot of the times in algebra problems, you just keep it improper, and that's perfectly fine. All right? Don't plug it into a calculator and give me a calculator answer. Just give me this answer right here. Okay? All right, that was old school. We're not doing exactly that. We're doing kind of like that, but I'll tell you what, I'll keep that up there. I was going to erase it, but we'll keep it up there. Let's now go to what we're going to do now. In algebra, we introduce letters and variables and well, letters and variables are the same, but exponents, right, and things like that. So that's the kind of stuff that we're going to do today. So let's go real basic here. What if I said A over B plus C over D, right? And I wanted to add those together. So what do? Well, B and D. What's the only way to find a common denominator if you have B and D? Multiply them together. So it's BD. Right, so that's your common denominator. This is pretty much identical to what we just did up here, but I'm just introducing variables just to kind of push you along gently here. Right, so we multiply these together and you get BD. Now, what do we do to B to get to BD? We multiplied it by what? D. So what do you do to the top? You multiply the top by the same thing, didn't you? Now, why do you do that? I want you to understand why we did that. If I multiply the top or the bottom by D, I also multiply the top by D. Is the reason because whatever you do to the bottom, you do to the top? You know how that one reason in algebra, whatever you do to the left side, you have to do to the right side? Is that the same with this? Whatever you do to the bottom, you do to the top? No, it's not. All right? Because if I added something to the bottom and I added the same thing to the top, that's not going to be the same thing. Right? Do you believe me? Watch this. What if I had like 3/4? What if I add something? Let's add a 2 on the top, and I'll tell you what, let's do it like this. Let's add a 2 to this and add a 2 to this. What do I get? I get 5 what? 6. Is 5/6 the same as 3/4? No, it's not. So is that little rule that a lot of people think, okay, and that's why I want to take a little bit of time to explain this, because a lot of people think whatever you do to the bottom, you do to the top. But if I added something to the bottom and I added the same thing to the top, it's not the same thing, is it? These are not equal to each other. So that's not the rule. The rule is you're multiplying by a 1. Right, d over d is 1, isn't it? So really what I'm doing is I'm just multiplying by a 1. Do I change it do I change the value of anything when I multiply by a 1? Not at all. It stays the same. That's why we can do that. All right. I know I'm getting a little basic, but when you're a little kid and you learn this in elementary school or whenever it was, the teachers probably don't explain that to you. All right. But I think in algebra they should explain it to you so you know why you're doing what you're doing. Okay with that? So what do we get right here? I know that was a lot of extra talk. I probably waste, but that's okay. What did you do to D to get to BD? You multiplied it by what? By B. So what do you do up here? You multiply that by B as well, correct? Now you could write CB, but I'm going to write it BC. Is that all right? And there you go. There's nothing else you can do with that. You can't add AD and BC. Over here you could add 21 and 20, but right here you cannot add AD and BC because they're unlike terms. So you just keep it like that and you just leave it. All right? There's no way to simplify that. That's as simplified as that'll get. All right, the same things works with subtraction, all right, if you wanted to do that. You okay with that? All right. Now, you got the basic idea of what we're doing. The hard part is sometimes finding the common denominator. So far, it's been pretty easy because this was prime, this was prime. You just multiply them together and you get your common denominator. You could always do that. You could always find a common denominator by just multiplying the two denominators together, right? But we don't always want to find just a common denominator. We want to find the lowest common denominator. Remember that, don't you? When you're a kid learning fractions, LCD, right? Lowest common denominator. Is that right? Lowest yeah, okay. Make sure I got an acronym right. So let's do this problem right here. It's 5 over 9x squared plus 1 over 6x. All right. Now this denominator is a little bit more difficult to find. And that's going to be probably one of the hardest parts of what we're going to do is just finding the common denominator. I want to show you a little trick though, because some of these, especially when these numbers get a little bit bigger. Let's see, I'm looking at the examples here. I don't really see too much of this, but I'll tell you what, I'm not going to go through that little trick. We'll wait till we get some big numbers and I'll show you later. But I've got a 9 and a 6. What would the lowest common denominator be? What's the lowest number that 6 divides into and 9 divides into evenly? Well, you could go 54, but there's a lower number than that. Is there a number that 6 divides into and 9 divides into? 18, right. All right. It's just a matter of looking at it and just saying, oh yeah, 9 goes in 18 twice, 6 goes in 18 3 times, right? There is a way to do it. I'll tell you what, I was debating whether to go through this. Now I'm going to do it. Watch. If I had a 9 and a 6, watch what you can do. If you could just say 9 times 6 is 54, but that's not your lowest. What you can do is this. You can take these and break them down into their prime numbers. So what times what is 9? 3 times 3. All right, and take 6 and break that down into its prime numbers. 2 times 3. All right. So basically, I've got 2 sets of numbers here. Okay. What I'm going to do is I'm going to find the numbers that show up the most number of times. So what about 2? I don't have any 2's over here, do I? But that's okay. They don't have to be in both places. But I do have a 2 here. So watch what I'm going to do. I'm going to circle it. I do have a 3 here and 3's here. Now, if they show up in both places, I take the one that shows up the most number of times. So do I pick one of these 3's or 2 of these 3's? 2 of them. So I'll circle both of those. Now, what do I do with both of those? Multiply those together. What's 9 times 2? It's 18. That's your common denominator. Do you see that? That's really handy. Now, with 9 and 6, you really don't need that little method. But when you get numbers that are quite a bit bigger and you can't really think of what the lowest common denominator is, then this method is really a nice way to use. Okay, and if we come across some problems where the numbers are really big and it doesn't look like any of these problems that you're going to do, you're going to have that, but I just thought I'd show you that anyway. Anybody show you that before? Okay, it's a nice little way to find a common denominator. Alright, anyway, so 9 and 6, what's the common denominator? 18. What about x squared and x? It's what's in common with both of them? Just the x, right? Okay, there's an x in both of them. There's not an x squared in both of them, is there? But there is one x in both of them, so it's 18x. That's my common denominator. You okay with that? So what do? We say, what did we do to this to get to this? What did we multiply 9 by to get to 18? A 2. So I'm going to put a little 2 here. what do we multiply? Oh, I lied to you. I lied to you. It's not x. I didn't really lie. I just wasn't thinking. I must have been thinking something else. I think I was thinking greatest common factor is what I was thinking. If I have an x squared and an x, it's what number do they both go into evenly? It would be x squared. So you take the larger. If you have variables with exponents, you take the one that's the larger one. Sorry about that. My bad. As the kids say today. All right. So what would we go? 9 times what? 2 is 18. X squared times what is x squared? Well, just 1. So all we did, no, not times x. It's just x. We didn't change it, did we? We didn't do anything to this x squared to get to x squared. So we don't multiply it by anything else. So really, all we did to this was just multiplied it by 2, didn't we? What about this one? What did we multiply this by in order to get to this? Well, 6 times what? 3. And then x times what gives you x squared? Come on, x times what gives you x squared? X. All right, and there it is. So now we can write this stuff out. That's a 10, and that's a 3x. And really, that's all we can do. There's nothing else we can do with that. We're done. It's not too hard, is it? All right. Do you think they'll stay that easy? Probably not. Probably not. So let's try another one. Now this one looks a lot crazier than what we've been talking about. Okay, we were pretty elementary before. Okay, now we're pumping it up a little bit here. Okay, so first thing we need to do is find a common denominator. But look at the denominators. Oh my word, that's crazy looking. How in the world am I going to find a common denominator with all that mess? Well, if you look at these, before we try to find a common denominator, it's nice if we have something times something else down here on the bottom. Like, remember that 9 and 6, like 9 was 3 times 3 and 6 was 3 times 2. It's nice if we could do that. Now, what could we do to this to make it so it's something times something else? We asked this question yesterday. Factor it. That's right. It's exactly what we're going to do. So I'm going to do this underneath just so I can see it right here. So I'm going to factor this thing. So if I factor it, there's a common y. And so if I factor out a y, I get y minus 1. Agreed? And then we factor this. So this is a trinomial. So you got to go through those steps. Actually, let's do this first. You know what would be a little bit easier? I'm going to do a little in-between step here. Is that all right? Look, what's in common with all three of these? Always look to see if there's a greatest common factor. Is there a greatest common factor here? 2. Right. 2 is the greatest common factor. Let's see what we get when we factor out a 2. We get y squared minus what? 2y plus what? 1. Good. Alright, so look at this. Now I should be able to factor that thing right there. Still got to put a 2 there. Don't forget about that. But now this factor should be pretty easy. Alright, and it's just y minus 1, y minus 1. Would you agree? If you add them together, or you multiply them together, you get positive 1. If you add them together, you get negative 2. And there you go. So there's my common denominator. So what I want to do, let's put the numerators in here. We're not even messing with the numerators just yet. What I want to do is I want to find one nice common denominator between the two of these. This is a lot easier now than what we did up here, than what we had originally. So what I do is look to see what numbers show up in both of them. Remember I put that line, remember I had that 6 and that 9 and I showed you that little trick? That little trick comes in handy right here. Because look, I've got this side, right? Think of this side, and you got this side, this fraction, this fraction. Well, what do I have? I got just a y by itself. Do I have a y by itself over here? No. I have a 2 by itself right here. Do I have one over there? No. So I just pick each one of those. So it's in 2's here and a y's here, so I'm going to put a 2 and a y right there. You okay with that? Now, I got a y minus 1 here, but I got 2 y minus 1's here. Remember what I said? Remember we had that 3 times 3, and then you had a 2 times 3? If it shows up more than one time, you pick the one that it shows up the most number of times. So y minus 1 shows up once here. Y minus 1 shows up how many times here? Twice here. Which one do you pick? You pick the one that shows up the most number of times. So you pick the one that shows up twice. Okay? Does that make sense? So that's what our common denominator is going to be. So we could write y minus 1 times y minus 1. Or you could write just what? Y minus 1 squared if you wanted to. All right? We'll just write it like that. Just a little close, just a little bit more succinct, a little bit more compact. All right, so that looks nice right there. Oops.